Yeah. Listen here. Focus here. So next our topic is negative series dipole with reference voltage. Focus here. My input waveform is what? Sinusoidal. Always your input waveform is continuous time periodic signal, that is sinusoidal input waveform. That is our input waveform. My heading is negative series dipole means what will start? Your diagram should start with anode and that's why anode and this is cathode. And always focus here. It is preferable. Have you seen this resistor in each and every diagram? Say some. A resistor is always connected across diode. I will tell you the reason. It is preferable. It is suggestible. Always the resistor should be available, should be connected across diode, because your resistor will limit the flow of current. It will take some amount of current. It will limit the current. So that maximum of amount of current should not flow to diode. If maximum amount of current go to the diode, your diode will burn. Your diode will burn. It's gonna suicide. For that purpose, we always connect a resistor across diode. Resistor is nothing but it limits the flow of current. That's why it is preferable to connect a resistor across diode. Clear? Say some. Now I will directly go to the operation. In this case, I won't use for positive offset. Keep in mind, I won't use for positive offset and negative offset. Here, there are different cases. I will directly tell you the operation only. Ardhamatunda clear? I will directly go to the operation. If your input is less than VR. This is my input waveform. Listen here. If your input is less than VR, that VR is nothing but our reference voltage. What is the maximum voltage? VR in general, but normally it is considered as 5 volt. Normally it is considered as 5 volt. Generally we say VR. Now focus here. What is my first case I am telling? V is less than VR. I will consider as being a user you, as being a user he, can consider the reference voltage. For our better understanding purpose, I will consider this reference voltage as 2. What is this? How much it is? 2. Focus here. This is 0, this is 1, this is 2. 3, 4, 5. Correct? 0.2, 3, 4, 5. Again what? 4, 3, 2, 1, 0. Now I am telling that if your input is below VR, my meaning is less than VR. Below VR means 0 is below VR, 1 is below VR, VR will be considered as below VR. I will write here, focus here. 0 is less than VR is how much? 2. 1 is less than 2, 2 is less than 2. 2 only we will consider like that. 0, 1, 2. Now what will be your output? Anybody in the class? No, I am telling that below VR, my range is this 2. I am considering below VR. VR 2 is less than 2 only. In this case, we are considered like that. To understand the better output, to draw the output properly, we will consider 2 is less than 2. Understandable? Consider like that to draw the better output. Because that is my sinusoidal waveform. This 2 can be, it will become 1.99 also. Ardhamainda clear? That is a sinusoidal waveform. That is not a distal input. It's not a distal input. It is a alternating current. 1.99 can be considered as 2 only. Say so. That is what I am considering. So anybody in the class, if 0 is less than your input is less than VR, what will happen here? What will be our output? Correct? What is that? Open circuit. Anybody else? Focus here. Everybody focus here. That's a major important concept. Focus here. I am applying 0. 0 means considered as positive. Say yes or no. 0 is positive. Positive to the positive, negative to the negative. 1, positive to the positive, negative to the negative. 2, positive to the positive, negative to the negative. But my reference voltage is how much? How much it is? 2 volt. My reference voltage is 2 volt. That is greater than your input voltage. Say yes or no. That is greater than input voltage. So where you will measure your output? Where you will measure your output? Across load. Say yes or no. Here you connect a wire. So that output, this reference voltage will become stronger than input voltage. Then your diode will be under reverse bias condition. Your diode will be under what? Reverse bias. Because 0 will not matter to this, 1 will not matter to this, 2 will not matter to this. Because my reference voltage is greater. Always will measure output across resistor. Then this will become what it is. If I draw this, what it is? Open circuit. Whatever you will apply, it will not matter here. It will be under reverse bias condition. Then your output will be 0. No, your output will be, you guys are wrong. Your output will be VR. Because I measure the output here. What is the voltmeter here? 2 volt. We are connecting a voltmeter. My reference voltage. I am giving that. That's why your output will be VR. Here you will measure. Understandable? Say yes or no. Don't need to make confusion. If input is less than VR, this VR will become strong. That will come into fact. Your output will be VR because this diode will go under reverse bias condition. Are clear? Understandable? Say yes or no. So this is first case. What will be my next case? V is greater than V. Focus here. This point. 3, 4, 5, 4, 3, 2, 4, 3, 4, 3 will be considered as what? Greater than input. Greater than VR. Sorry, greater than VR. Then what will be your output? I am telling that V is greater than VR. Focus here. My input is 3. It is greater than 2. My input is 4. It is greater than 2. My input is 5. It is greater than 2. These cases. 3, 4, 5. 5, 4, 3. Are the clear? Understandable? Then what will be your output? Anybody in the class? Focus here. Now I am applying 3 voltage. That is more positive. Say yes or no. 3 is more positive than 2. Say yes or no. Yes. Or more positive to anode end, negative to the cathode end. What will happen to the diode? Forward bias. If it is under forward bias condition, what will be your output? V only. Your output is V only. Just previously you have seen. If it is under forward bias condition, output is V in. I am applying 3, which is more positive than 2. I am applying 4, which is more positive than this 2. I am applying 5, which is more positive than 2. Then diode will consider this voltage 3, 4, 5. Positive to the positive, negative to the negative. Diode will comes under forward bias. If it is under forward bias, my output will be input voltage. Clear? Understandable? I will repeat it. If V is less than VR, 0, 1, 2, your reference voltage will become stronger. This will not come into fact. Diode will be under reverse bias condition. I measure the output here. My output will be VR only. If input is more than 2, 3, 4, 5, 5, 4, 3, then diode will be under forward bias condition. Then input will appear across output. My meaning is VOT is V in. Understandable? Say yes or no? Yes, sir. Now we draw the output waveform. Focus here. Listen here. Don't draw it. Listen here. I will draw. If you will hear it, it will become easier. If input is 0, what is my output? Yeah. If input is 0, input is less than VR. Where is VR here? Here it is. Put a dot. My input is 1. What is your output? Yeah. So here you take a line and put a dot here. This line is VR. My input is 2. What is your output? VR only. Here it is. Here. Now my input become 3. What is your output? Like this. My input become 4. 4. My input become 5. 5. This is maximum. My input become 4. 4. 3. 2. Like this. Up to here. Up to here. You will get a VR only. You will get a VR. Because -1. See here, my input is -1. -1 is less than 2. Say yes or no? Then your output will be VR only. VR. For entire negative half cycle, your output will be VR only. Understandable? Now again my input become 3, 4, 5. Say yes or no? Then 3, 4, 5. Again this VR. Understandable? That is your output. Output will look like this. VR 3, 4, 5. VR 3, 4, 5. PR. What you understood by this? What is your topic? Negative series flipper. Where it is slipping? Which portion is slipping? Negative portion. Also positive portion is going to flip. So focus here. Negative series flipper with reference voltage will remove the portion below VR. What is this? What is this portion? Below VR. So portion you need to write down like this. Portion below VR stripped off. Understandable? This is VR. Below VR, whatever the waveform is there, trimmed, clipped off. You can see here. This gone. Only left is above VR. So negative series flipper with reference voltage will remove the portion below VR. It will clip off the portion whatever the below VR is there. This complete portion gonna clip off. Understandable? I have drawn the arrow mark. That complete portion gonna clip off. Clear? Yes or no? Okay. Listen here. If it is negative series flipper, how your diode will start? Positive end. Your diode will start with anode end. And I am telling my topic is with reference voltage. You need to draw a reference voltage here. And you should connect a resistor. And that here it will become your input. Here you are connecting your input. Input means you are connecting, you are giving a voltage. Either you connect a voltmeter, multimeter, any voltmeter. Have you seen voltmeters? Just connect voltmeter here. As being a user, you will give the input. A resistor, some resistor, 1 kilo ohm, whatever it is. And this reference voltage, someone have asked me, as being a user, you will give this reference voltage. Here also you will connect a voltmeter or multimeter. And you are taking this reference. As being a user, you will give reference. How much that is? Yesterday I explained how much it is? 2 volt. Maximum is 5 volt. Don't take maximum reference voltage. The reference voltage should be less than 5 volt, more than 2 or 2. So that you can understand the diagram. You can understand the output properly. Understandable with this? What is this? Positive, negative. Anode. So I directly go to the diagram. What is your input waveform? How it looks like? Always it is a sinusoidal. 0, maximum is Vm. This is your input. I am taking reference voltage as here. Here it is your reference voltage, and that is Vr. in my case VR is equal to 2 volts. This is 0, this is 2, 3, 4, 5, 4, 3, 2, 1, 0. Like that by putting a dot, by making a lines, you understand by yourself. Just assume that it has 1, this has 2. And what it will be? Minus 1, minus 2, minus 3, minus 4, minus 1. Like that. This is positive, this is negative. Maximum voltage is plus Vm, minus. This is negative is minus Vm. Here also you take a reference voltage minus Vm. And this is pi, this is 2 pi. From pi you draw a dotted vertical line. From 2 pi also you draw a dotted vertical line. And here you draw your output. And x-axis is time period, that is nothing but omega t. Time period 0 pi, 2 pi, 3 pi. And wherever this VR is intersecting, draw vertical line. Wherever your VR is intersecting, here VR is intersecting, draw dotted vertical line. Here also VR is intersecting, draw dotted vertical line. And at the negative end minus VR. This minus VR is intersecting. Here put a dot. Here you put a dot. Draw a dotted vertical line. For your better understanding purpose, to draw the output properly. Understandable? If you draw these dotted vertical line properly, you can join them. You can draw the output properly. And here it is. Clear? Understandable? Yes or no? So here, while trying the output, make it as Vm, make it as Vr. Make it as minus Vr, make it as minus Vm. Vm plus Vm, minus plus Vr, minus Vr, minus Vm. Done, understood? Now I will directly go to the cases. There are two cases. The first one is if your input is less than Vr. I am telling that your input is less than Vr. My VR is how much? How much? That is 2. Suppose you are applying the input voltage 0. 0 is less than 2, it satisfies the condition. 1 is less than 2, it satisfies the condition. 2 is less than 2, means 1.99. That is a sinusoidal waveform, that is not a digital waveform. Keep in mind, that's not a digital. Sinusoidal means it goes like this. It will be considered 1.99 will be considered as 2 only. 2 is less than 2. In this case, focus here, listen properly. I am applying the 0. This voltage is how much? 2. Positive to which end? Negative. Negative to which end? Positive. Then what will happen? Reverse. Because this is 0 and this voltage is more, this voltage is strong. Means negative is getting positive, positive is getting negative. Anode end, you need to focus here. If your anode, this is becoming more. If you are applying 5 here, then it will become strong. Say yes or no? So in this case, if it is under reverse bias condition, what will happen? What is this? Open switch. Means remove this. Open switch means remove this. Then what will be your output? Why 0? VR. What is your output? VR. Someone is saying 0, I will tell you. I will tell you focus here. If the wire has been removed, I have removed open switch means I have removed the wire. Where you are measuring the output? Focus here. Where you are measuring the output? Here we'll put a 2 wires. Any voltmeter, any digital ammeter will connect here. What is voltage available here across here? 2 volt. So what is your output? 2 volt means VR. VR is 2 volt. That is. Understandable? Now second case. If your input is greater than VR. Greater than VR means 3 is greater than 2. 4 volt is greater than 2. 5 volt is greater than 2. Now this is your diode. I am applying 3 volt here. 3 is greater than 2. Say yes or no? Anode becomes more positive compared to this cathode. Then what will happen? Your forward bias, it will act as a closed switch. So whatever your input is applying, that will be available here. Then what is your output in this case? V input. So focus properly. If it is under forward bias condition, output is input only. If it is under reverse bias condition, in this clipper, output is VR. So based on this diagram, this is 0, 1, 2. My input is 0, 1, 2. What is your output? VR. What is your output? 0, 1, 2. So VR. 0 for 0 VR, for 1 VR, for 2 VR. So join this. My input becomes 3, 4, 5. Again 4, 3. What is your output? B means 3, 4, 5, 5, 4, 3. 3, 4, 5. Up to here. So join this. Understandable? Again my input becomes low. 2, 1, 0. What is your output? VR. So here, up to negative half cycle, up to here, your output is VR only. Up to here, your output is VR. Understandable? Just put a dotted line for your better understanding purpose. I am drawing, I am completely drawing. Put a dotted line, and join them. Now again, at this point, my input becomes 3. Say sir, no. 3 is greater than 2. What is your output? Bean. Bean is 3. 3 only. So here it becomes 3, 4, 5. 4, 3, 2. So join it. Again, it will become like this. So, what do you mean by this? Negative series clipper with reference voltage, what it will do? It will remove portion below VR. Below VR, whatever the portion below VR is there, that gonna remove, that gonna cut, clip off. Understandable? Clear? If your voltage, input voltage is greater than VR, then only it is under forward bias. If it is less than VR, it is under reverse bias. Hope understood this clear? Say sir. No, I did not draw the transfer characteristics yesterday. Let me draw that. How will you draw transfer characteristics? Your y-axis is, what is your y-axis? No, V out. Your y-axis is V out. Just only I drawn the previous topic. What is your x-axis? V in. What is the total maximum range? 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right now, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And this is as simple as it is. You guys do lab, just drawing the graph, measuring a scale. 1 unit, 1 centimeter is equal to 1 unit. Minus 1, minus 2, minus 3, minus 4, minus 5. This is minus 1, minus 2, minus 3, minus 4, minus 1. Minus 1, minus 2, minus 3, minus 4, minus 5. Now take those two cases. And what you need to do? You need to consider VR. What is this? VR. This is VR. Write down here VR. If your input is less than VR, what is your output? VR only. 0, VR only. 1, VR only. 2, VR. Join this. Understandable? 0, VR only. 1, VR only. 2, VR only. If it is more than 2, what is your output? V input. 3 means 3, 4 means 4, 5 means 5. So join this. Understandable? Join this. Here you write down D out. Here you write down D out. Now if your input is less than VR, means minus 1, minus 2, minus 3, what is that? VR only. Minus 1 VR, minus 2 VR, minus 3 VR, minus 4 VR, minus 5 VR. Join this line. Here you write down clip off. And you can mention D off. There you write down D off. Clear? And join this. Understandable? That is your transfer characteristics. Based on the process, based on the equation, you are drawing that. You can note on it. You can draw the diagram.